Okay. So thank you again so much for inviting me to come present for our Ladies Baltimore. I am so excited to be here, so excited to present here, and so excited to talk with you all about how to use R with Excel. So before I get into how to use R with Excel, I'd like to get into why I'd recommend using R with Excel by starting with a simplified timeline of my career. So my first jobs, my tool of choice was Excel. I didn't know any programming languages at that point. I didn't know about R. I basically only knew Excel because I had been taught how to use it in like elementary, middle, and high school here in the United States. So, but as I went along in those first analytical jobs, I realized that there were limitations to using only Excel for data analysis. And I've included like the top 5 limitations that I found here on this slide. So the first one that I found was that there's limitations in importing and manipulating data. You can't really import any other kinds of files other than other Excel type files or text files or CSV files. Like you can't import things from import things produced by other proprietary softwares like Minitab, SPSS, and Stata. And there's limitations to how you can manipulate data outside of any kind of tabular format. So that was one thing that kind of bugged me. And then another limitation of using only Excel was that it was kind of difficult to automate or reproduce complex tasks that you can do in Excel. Now, VBA can solve some of those problems if what you're automating or trying to reproduce is relatively simple. But if you're trying to work with hundreds of Excel sheets or trying to work with extremely large data sets, which I'll get into in a moment, it's much more difficult to try to automate or reproduce what you have done before in Excel or like what your team member has done before in Excel in terms of trying to locate what formulas lead to what and what exactly they do. It's very hard to track all that down. Also, it's very hard to work with large file sizes in Excel, whether you're importing like a text CSV or just like another Excel type file. Excel has an actual file limit to what it can work with and what it can open. I believe it's around 1,048,000 rows and around 16,000 columns, which I mean sounds pretty large, but like when you're trying to like combine like millions of like transactions, like when I worked in financial services or like work with tons and tons of just other types of data like genomics data, for example, when I tried that, it was just it's unmanageable to try and work with large file sizes with only Excel. Also, I found it difficult to try to debug or fix errors in Excel because oftentimes when there's an error in a formula, it will just give you something unhelpful like the hash sign and then the word error in all caps, or the hash sign and then the word NA in all caps. And it's hard to track down what cell made the wrong formula, or like if you're working with VBA, it's kind of hard to debug that too because it's hard exactly to locate where in the spreadsheet and in what spreadsheet the script made an error. Finally, there's another big limitation of using only Excel in that it has some mathematical capabilities, but it doesn't nearly have as many mathematical or statistical capabilities as R or Python do, especially R. It doesn't have advanced statistics and machine learning techniques. It can only really do like summary statistics and like running simple regressions or splines. So this led me to, in my next analytical jobs, just switch completely to programming because I was kind of done with Excel at that point. I was kind of frustrated with its limitations, and I'd heard of that like Python and R could potentially alleviate all of those like restorations and like mend all of those like limitations. But as the time went on, I found that there were some limitations to using only R. Like when I was first learning R, I only came upon resources to learn base R. And so I found it hard to learn the core tool set at first because base R I found to be pretty unintuitive, to say the least. And then also very different in style compared to like a graphical user interface like Excel, where you could just point and click at a cell and then look through some intuitive menus to figure out what to do. Whereas with R, you have to like, at least when I was learning it in the beginning, look through like Stack Overflow pages and things to try and figure out what to do. And then another limitation using only R is that it's kind of difficult to enter data manually into a tabular data type object or like a data frame. Whereas in Excel, you just point and click at a cell, you can enter in some numbers, hit enter, and then you're done. But like in R, I found it difficult where you had to know like the row number and the column number of what you were trying to do if you were trying to enter in like a specific cell in a data frame. Or like if you were trying to replace a column, have to know like the column name. Yeah, it's just a lot easier to enter data manually when you can kind of visually see it in front of you. And then another limitation of using only R that I found at first was preserving specific Excel formatting, specifically in this case, in the case of data tables and pivot tables and power pivot tables, those aggregated types of tables that you often see in Excel. I found it hard to like enter those into R and like preserve them at the end of my R analysis. And then another thing was deciphering the graphical user interface. When I was first learning R, I just knew to download R, and I tried using just the R console, but that was very difficult to figure out like how to find outputs. But then I discovered RStudio and it made it a little bit easier, but still, like as someone who was unfamiliar with programming before like learning R and Python, like learning about what's the console, what's the terminal, what's the environment, and how do these all interact, that was a bit confusing at first, and that had a little bit of a steeper learning curve than learning how to use just Excel. And finally, another limitation that I found of using only R was that it's a lot easier, I've found in Excel, to like scan spreadsheets quickly and like instantaneously and visually. Like it's a lot easier in Excel to just quickly use some keyboard shortcuts to go to the first cell in the first column and first row, and then the last cell in the last column and last row, and then like maybe filter things off of that, or just do some really quick ways to like scan through your data than like in the visual data frame interface in like RStudio. So finding that there were limitations to both exclusive approaches, I decided to use a more inclusive approach by using both Excel and Python and R in my career, and that's what I've been doing in my current work, using both Excel and Python as workflow and at the same time. I found that using R with Excel gives me, at least, and data scientists defined broadly here as anyone who works with data, the best of both worlds, and that each of them working together gives each of their advantages. Like for example, like Excel makes up for one of R's disadvantages by having a very easily decipherable graphical user interface with just a plain spreadsheet GUI and easily readable menus that like in my presentation today, I've outlined a 5-step framework for how I recommend to use R with Excel. 1, read, 2, edit, 3, tidy, 4, visualize, and 5, share. The first step, read, means basically reading an Excel worksheet into R, whether just as a simple data frame or as an entire workbook with all of the formatting preserved. 2, edit means like how do you edit data in R like you can with Excel, in terms of like the simplicity of it and also like the visual GUI spreadsheet component of it. 3, tidy, how do you tidy data and like aggregate data in R like you can with Excel in like a data table or a pivot or power pivot table. 4, how do you visualize data like you can in Excel, but with the more powerful graphics capabilities of R, specifically ggplot2. And like also, how can you make a visualization in R that you can then write to an Excel file for someone else to use and read? And then finally, 5, share. How can you share the results of your analyses with other people, like your boss if you work in industry, or like other researchers if you work in academia? Also, how can you like share the data that you've written to a file in Excel, assuming like you have the permission to do so? So that's pretty much the 5 steps, like summed up like at a bird's eye view. But I'm going to be going through each of these 5 steps with its own R file. So each of these 5 steps has its own R file that I'll be working through with you to show you exactly how to make these things happen. So all of these files, like including this presentation that I'm showing you, and all of the R files I'm going to show you, are up on the GitHub repository that Dr. Taub showed you. And yeah, you can feel free to follow along with the presentations or you can feel free to follow along with the R files as I go in your RStudio console, or if you don't have RStudio installed, that's totally fine. You can just feel free to watch along, whatever floats your boat, whatever like you'd enjoy most doing, like feel free to go ahead and do that. So yeah, without further ado, I'll go ahead and go into the first step of my recommended workflow. How do you read sample Excel data into R? So go ahead and go to RStudio and open 01_read.r.
Oops, sorry.
Okay, so I've tried to make the font size big enough to read in my RStudio console, but please feel free to type in the chat if it's too small or if you'd like me to make it bigger. So yeah, so in this first script, like all my scripts, I included the packages here at the top that I'd recommend you install first before you try to run the code in the script. And then also, before I get into reading the Excel data into R, I'd just like to offer a brief primer of the data. So as you can see here, we're going to read in a file called penguins.xlsx. And basically, to shift to another tab, this penguins data was written to an Excel file from the data that's included in the Palmer's Penguins package, written by Dr. Allison Horst. And it basically contains size measurements for 3 different penguin species observed on 3 different islands in the Palmer archipelago of Antarctica. And as you can see here, they're adorable. They're the chinstrap, gentoo, and Adelie penguins. And that's basically the data that we'll be working with today. So back to the R file.
Alyssa,
yeah.
You think you could make it a little bit bigger, the font here?
Yeah.
At least one person posted it in the chat, and I'd like it a little bit bigger too. So there, I could express my opinion. Thank you.
Okay.
That's great.
Okay. Let's see. See if I can make this. Okay, there we go. Okay, and then so the main package that I'll be using throughout this workflow is called OpenXLSX, which in my opinion offers the best round workflow like offerings that you can use, and I'll explain more about that in a moment. But first, I'm going to go ahead and show you how to read in this Excel file as a data frame with the OpenXLSX package. You just simply take the read workbook function from the OpenXLSX package, and you specify the directory. Here I've specified that it's the penguins file in the data directory. And so with this function from the OpenXLSX package, you can read in this data as a data frame, which is the standard data object in R. Okay, and then we can see that it successfully did it. And then in the environment up here, we can see it successfully added it to our environment. And then this is another way to read Excel data into R, instead of just reading in the data as a data frame, which is like native to R, into R. You can also read in an Excel file as a complete workbook. which includes not only the data, but it also includes all of the formatting that comes with the data in Excel. So you can do that with load workbook instead of read workbook. And to run this line of code, you can press Control Enter, and boom, we have the workbook object inside of our studio environment here. Now, there are many other ways to read Excel files into R. The first of which is to use the read Excel package. Now, the read Excel package, like, don't worry about like trying to write down all the details I'm about to say because they're in the appendix, but like in the GitHub repo. But like the read Excel package is a lot faster than the OpenXLSX package at reading Excel as a data frame into R. It's about 2 times faster. But the only drawback of that is that it's only functionality is really reading Excel files as data frames into R. So if that's the only thing that you want to do with Excel, this is the package for you. And you can see the line of code example here. You can also read in specific sheets like you can in OpenXLSX. Also, there's a few other ways to read Excel in as both a data frame and as a workbook into R with the Excel Connect and XLSS packages. Both of these packages have Java dependencies, so I generally don't recommend them over OpenXLSX, which only has an RCPP dependency and is generally a lot faster and a lot easier to work with. But I decided to include them here because some people prefer these packages for their workflows because I guess it works better for them. So Excel Connect, the name of the function is pretty similar. You can do that. And then also for XLSX, again, pretty similar workflow here. Okay, so going back up here to what we did with OpenXLSX, recall that we've read in an Excel file as both a data frame and a workbook. So how can we see this data in R? Well, there's a few different ways. I've put the most popular 2 ways in this script. The first way is to just view the first 6 rows of the tabular data frame in the console. And once we run that code, we can see the first 6 rows, and we can see that there's different, well, there's just like the daily species that we can see, but there's different species of penguins and the islands that they were observed on and their different body measurements and when those measurements were taken. And then you can also view the entire Excel file by using the view function. I wouldn't recommend this for larger files, but yeah, this is a fairly small enough file that I can view it here. So see, with the view function, you can view it in kind of the same tabular spreadsheet format as you can with Excel. Note that you can't edit it here like you can in Excel. I'm going to get to that later, but you can still filter things like this. Well, you could still sort things, excuse me, like this, or like filter things. So like if you just wanted to show a daily, it just shows a daily. Pretty cool. So that finishes up this first step of 5 in my workflow. I'm going to go back to my presentation real quick. And that leads us into the second part of our workflow, which is how can we edit our data as an Excel? And we can go explore 02_edit.r to show you how to do that.
Can I pause for 1 second? And there have been a couple of questions in the chat.
Oh, yeah, of course.
Well, about the reading. So someone was asking about preference for OpenXLS to read Excel, and the issue of Java came up, which I think you basically addressed for the XLSX package.
Yeah, the OpenXLSX package doesn't have Java dependencies. It just has the dependency of RCPP. Yeah, which again, like doesn't have any of the pains of working with Java that I've experienced. Excel Connect and XLSX have the Java dependencies or are a little bit tougher to work with.
And you'll probably get to this later, though, about writing files to Excel and which packages you like for that. I think you said you're going to talk about that later on, so we can revisit if there's still questions after that. The other question was, can the view have filter criteria to show only the top 5? So again, this is just the view functionality in in our studio.
Yeah, I don't think that you can do it within the view. However, you can do like, here, let me show you. Head, penguins. And then you could save that to another data frame and then view that, or you could just simply do this and then it can show you the first 5 rows like that.
Great, thanks. Those were the questions.
Yeah, no problem. Okay, so moving into the second phase, editing, how do you edit data in R as in Excel? Again, I've outlined the packages to install up here. And then I'd recommend loading the tidyverse, as we'll be using the tidyverse to edit Excel data in R. So before I get into editing the Excel data in R, just to provide some cleanliness and some cleaning to keep the analysis clean, I'd recommend adding a worksheet to our current Excel workbook that we're working with. So I'm taking our Excel workbook that we imported in with all the formatting and everything, and then I'm adding a worksheet to it and I'm naming it sheet 2. So let's just do that really quick. Okay. And then we can now use the tidyverse to manipulate this data frame by removing the first column and then dropping rows containing NAs or missing values. It's okay if you don't completely understand this code, if like you're not familiar with the tidyverse. There's a lot to the tidyverse, and like learning the tidyverse can take up its own like 4-hour plus tutorial. Like it's a lot. Like it's really easy, but there's just a lot of content there in the tidyverse. It's very powerful is what I'm trying to say. So yeah, anyway, back to this. We're taking our data frame that we read in from penguins, we're removing the first column and we're removing all missing values. Oh, I forgot to load the tidyverse. That's why. There we go. And it worked. Okay, so now we can take this edited data frame, write it to our workbook in sheet 2, the sheet that we just added. So we can do that with the write data function from OpenXLSX. Boom, done. And then to check to make sure that it works in our little workbook object that we have in R, we can open a temporary version of that workbook. It doesn't mean that we're writing it to anywhere yet or that we're making any like permanent commitments. We're just like opening up a temporary version to check to make sure that it's working. So here we go. An Excel sheet should be opening. Here we go. And in the first sheet is our original raw data as expected. And then in our second sheet, we can see that that first column, which is the numbers, is missing, and we don't see any NA observations. So we successfully removed the first column and got rid of all missing observations as expected. Okay, so there are a few additional methods, like in the read file, for editing Excel data in R. You can use XLSX or XL Connect to do it. And then there's also this really cool new package called the data editor package that can emulate like an Excel spreadsheet inside of R. So I'm going to show you how this works. Okay, so you can see here, we kind of have the same spreadsheet view as Excel or as view we saw up here, but this time you can edit it just like in Excel. So we can just type in a number here, like I'm just putting in 38 because that kind of looks like the other numbers. Or even if it already had an existing number, you can write over that. And then you can also filter it. You can filter rows with different conditions. You can like only select columns that you want. And then the best part is that you can save what edits you did to your data frame to another R object, like I did right here, or you can even just directly save it to a file. Very cool. Although it's a bit more manual than like, running R code, like lines of R code. I still recommend it to people who are just transitioning from Excel to R because it's a bit it has a bit of a less steep learning curve than trying to like write code from the get-go when you've never written code before. So yeah. And then that finishes up this section. Were there any questions in the chat, Dr. Todd, about this?
There's one, I think, from the previous section, actually, was about reading multiple sheets in OpenExcel. And I said I thought it was a load workbook function that you shared, but was there anything else about that reading multiple sheets topic?
Yeah. All of the packages that I showed you have that capability to read in multiple sheets as multiple data frames. OpenXLSX, ReadExcel, XLSX, and Excel Connect all have the ability to do that. Yep.
Cool. Could I ask a quick question? When you were saying, when you have that pop-up and you were editing, is that function itself just saving that as that R object? Like when does that make sense, the question that I'm asking? Sorry.
Yeah, it's as long as you specify, here, let me go back to the RStudio. As long as you specify that you want to save whatever you're doing with data editor to an R object, then it should save what you're doing to an R object.
So whatever edit you make because of that function, it's already going to save that in that object. Perfect.
Yeah.
Thank you.
Yeah, no problem. Any other questions about, I guess, parts 1 or 2 before I move on?
Someone else asked if it was possible to roll back changes made in the manual edit.
I'm not sure. I don't recall if there's like an undo function here. Let me try that really quick. Okay, so I'm gonna do 39.3. Then let me see if Control Z doesn't work. But I mean, you can go back and do like that. Yeah, I guess as long as you don't save it to an R object, then you should be able to, it should restart from wherever you started.
What about that
yeah.
circle icon?
That's select column.
No, the arrow one, that looks like go back.
Synchronize. Yeah. I don't think that undoes things. I just think that synchronizes the changes that you've made to the R object. Yeah, I hope that helps. So, any other questions on parts 1 or 2?
I think that was it. That was in the chat anyway.
Okay. So moving into part 3.
Sorry, Anna, did you have a question?
Yes, yes, excuse me. I think so when we're learning today. I have a doubt in relation to reading an Excel file. That's when we have an Excel file, we are able to have 2 heads for the same column. For instance, if I have a database related to waste collection, I can put the name of the index that's on the top column Excel, and in the cell just below I put the unit of measures of that. For me, this is a big challenge when I work in R, because you can produce a number from R, and then afterwards you have difficult to classify this second head. I don't know if I was clear on my question. Hello?
Yes, thank you, Anna.
Yeah, thank you.
Did you understand the question, Elsa? I think I got it. But
Yes.
I'm not sure I completely understand your question. I would encourage you though to perhaps like ask it again after like the end of my presentation, or like email me your question via my website, because I'd love to help you with that. But
I think what she was asking was that in Excel, you sometimes can have, say, multiple column header rows. So she would have like the name of the column, and then she'd have the units in the next row below that. Whereas then when you read that into R and it puts it in a data frame, or I don't know exactly what happens when you make the sort of workbook object. What happens when you have then multiple data types, for example, in the same column, or I don't know, that's what I would imagine being the challenge there.
Yeah, for
Yes.
multiple data types, it preserves those, which is pretty amazing, quite frankly. And then also for multiple like rows that can serve as columns, I know that at least OpenXLSX and ReadExcel can accommodate that. I'm not sure about about XLSX and Excel Connect.
Okay, thank you. After I will send an email. Thank you.
Yeah, no problem.
There was
Thank
one
you.
more question in the chat about a strategy for reading in a large number of Excel files. Like if you had 100 Excel files that you wanted all into the same R object.
Okay. Yeah, if you just need the data from those files and you don't want to preserve the formatting or anything fancy, I'd recommend the ReadExcel package for that, because that would be able to handle it the most efficiently and read in the files the most quickly. However, if you want to preserve the formatting of all of those files, then I would recommend the OpenXLSX package for that. And both of those can handle that.
So can you basically read it in and concatenate them somehow into the same object, like the same workbook object or something like that? Is that how that would work? Or
into this, yeah, if you're just reading in the same data, then you can, yeah, concatenate that.
I mean,
into the
sorry, no,
same
I'm
data
saying like
type.
I'm not being clear. It's like if you read multiple workbooks, but you can then add them to the same R object that has each one still a separate.
Yes, yeah, you can do that too. You can add that to a workbook, a special workbook object with the preserved formatting.
Okay.
Okay.
All right, I think that was it for the questions for now.
Okay, keep them coming. So for the third step, I'm going to show you how to tidy and format data in R like you can with Excel for more streamlined analyses. So back to RStudio for the third file. Again, I have the recommended packages, recommend loading the tidyverse. And then again, to segment this analysis from our previous analyses, I'd recommend adding a third sheet to our workbook with Add Worksheet. And here I've summarized the penguins data into a sort of like small pivot table. Here I've done a relatively simple example where I've grouped the edited data from produced by our previous script by species and island. And then I found the mean flipper length and body mass for each penguin by island. So here we go. And then I've successfully done that. And then by creating, or actually, I think it would be a good idea to show you what this looks like in R before I show you what it looks like in Excel. So just really quickly. There we go. This is pretty much what it looks like in R. We can see that it generally has the pivot table structure and that it has like these aggregated means grouped by each species and island, but it doesn't have the same kind of formatting of Excel with that. So this function by OpenXLSX does that with write data table, writes to the workbook into sheet 3, the sheet that we just created above, takes that object that we just made above that aggregated it, and then we can also specify a table style. In this case, it makes it a nice light blue kind of table that just like what you would see in Excel. So here we go. Let's write a data table. And then again, we can open a temporary version of our Excel workbook to see what this looks like in our Excel file. Okay, again, sheet 1, raw data with all the NAs in the first column. Sheet 2 removes the first column and all NAs. Sheet 3, what we were just working on, boom, we can see a very nice Excel formatted table with the calculations that we just made in R and the tidy data that we just made in R. Again, there's additional methods to do this. You can also make nice tables just and like pivot table like objects with XLSX and Excel Connect. And then you can also do a lot more than just like simple pivot table, like aggregations and like tidying like that with the tidyverse. As I mentioned before, there's a lot of things that you can do with the tidyverse. It's very powerful, and I'd recommend that you like explore as much as you can with the tidyverse. So any questions on this section?
I don't see anything in the chat. Anybody have any questions? Guess not.
Okay, so I'll go ahead and move on to the fourth step in this workflow, which is to visualize data in R analogously to Excel. So let's have fun with the fourth R file. Go ahead and close this. So again, we're going to be using the tidyverse to visualize data, specifically the ggplot2 package. Before this, again, let's segment our analysis. Let's take our workbook, add a fourth sheet. Oh, I was just highlighting sheet 4. That's why it worked that way. Okay, there we go. Now we've added a fourth sheet. So again, let's use ggplot2 on our edited data produced by script 2. We're going to be taking the island and species and produce a visualization of the counts of each species by island so that we could see how many penguins of each species were found on each island. And I borrowed a lot of this ggplot2 code from the Palm Penguins documentation. So we can make the plot, save it to this object, and then we can print the plot. And then we'll see it pop up over here. I'm going to go ahead and enlarge this really quick so that you can see what it looks like. And you can see that we have this wonderful visualization of how they found Adelie penguins on all 3 islands and like how many there were. And then you can also see that chinstrap penguins were only found on Dream Island and Gentoo penguins were only found on Bisco Island. And there were more Gentoo penguins found than chinstrap, and kind of hard to tell with the total of Adelie, but you get the picture. It's a pretty cute visualization. And then like this is like just like a general example of what you can do in terms of like visualization in R, but there's so many other like packages and other options to do to make visualizations in R. But anyway, so we can write this visualization as an image to the worksheet that we just added to the Excel workbook by using the insert plot function from OpenXLSX. Boom. And then again, we can check to make sure that that wrote the plot to the Excel workbook with OpenExcel. Okay, first sheet, raw data, second sheet, again, third sheet, fourth sheet, we have our visualization. Now, again, what I'm going to be saying now in terms of more details can be found in the appendix, but I just like to note that as of right now, this is the only way that I know of to embed visualizations from R into Excel. Like as of right now, I don't know of any other packages that can embed Excel native or Excel editable plots into R. Like the only implementations that I know of can embed images like this from Excel into R. And then I guess there are 2 ways in R that I can think of to embed Excel native or Excel editable plots into R, which is one to write VBA code to produce the chart and then run that VBA code from R. And then the second way would be to use the Python package XLSX writer with the R package reticulate to produce the chart. And then also kind of in a related way, there is an R package to make Word and PowerPoint native visualizations, and that's called the MS chart package. So if that fits your needs, feel free to check that out. And then also I just like to note for fun that there's a ggplot2 theme. This again was made using ggplot2, but there's actually 2 ggplot2 themes that you can use to make your visualization look like it came from Excel. There's one that makes it look like it came from like a 90s version of Excel, and that's like theme_Excel. And then there's also another ggplot2 theme called theme_Excel_new that makes your visualization seem like it came from a more current version of Excel. So just wanted to make sure to point that out.
We have a few questions in the chat about the visualizations. It's a good time for that. One was asking about how to make the colors coordinate with the islands rather than the penguins.
Yeah, that's a ggplot2 question. Let's see. I'm not entirely sure. I haven't. Oh wait, I think
you just do fill equals island instead of. Oh no, that's not true because.
Yeah.
Hang on.
I was thinking it had to do with fill, but then I was like, wait.
Yeah, I mean, I think that I'd have to play around with it too, because this is the usual. Yeah, I think you do fill equals island, but I'm not sure. Then you kind of lost that you're, oh yeah, because you're facet wrapping on species. Yeah, if you just do fill equals island, I think that will work.
Okay, yeah, I agree.
Teresa agreed with that too. So I believe that will work.
Yeah.
So then there are a couple other questions. Someone was asking, oh, one of the questions was, can you edit the graph in Excel? I think you already mentioned that the answer to that is no, right? Because it's an image, not an actual Excel graph object.
Yep, correct. Yeah.
There's a question about whether you can insert the plot at a specific location in the spreadsheet.
Yes, yes. You can specify the specific cell or cell range that you want to insert a graphic, or really any of the things that I showed you, like a table or data in Excel. Yep.
And then there was one more question about the best way to work with dates from Excel in R.
I'd recommend the LuberDate package. That in general works with dates pretty well, whether they're imported from Excel or from any other data source. Yeah.
All right. That was, I think, all of the questions for now.
Okay, cool. Going back to my presentation, we're moving into the fifth and final part of this workflow called sharing. How do you share the data and results from your analyses? So let's go back to our fifth R script. Again, I have these packages up here. I recommend you install. Again, loading the tidyverse package. And then this is by far the simplest and least involved part of the workflow. With OpenXLSX, it's very simple. You just have this one function called save workbook. You specify the workbook that you want to save or write, and then you specify where you want to write it. So in this case, I'm writing it to another Excel file called penguins_openxlsx.xlsx. But you can also overwrite, if you so want, like your original Excel file, like by just naming it the same as your original Excel file, like you would get rid of this. And then you would also have to specify in the arguments for this function, like overwrite equals true, and then you can overwrite your original Excel thing. But just for simplicity here, I made it a different Excel workbook. So let's just go ahead and run this line. Boom. And then by looking at our files, we should see it's right there. And then I can go ahead and open it from here. And again, we should see what we saw last time with the preview after the visualization. We have the raw data here. We have the edited data here. We have the tidy data here. And then we have the visualization here. Alrighty. And then again, like I showed you in the read R script, you can also do this with Excel Connect and XLSX. And then like read Excel is for reading Excel data into R, write Excel is for like efficiently writing Excel data, from R, or just writing like a data frame to an Excel spreadsheet. So write Excel, like read Excel, also is about 2 times more efficient than OpenXLSX because it has no dependencies like read Excel. So it's just a lot faster, and it's also easier to work with and more portable across different operating systems and systems. Yeah, and gosh, I'm blanking on the word, but yeah, different operating systems and platforms. There we go. And then Write Excel also has some pretty cool capabilities, like it can write formulas into specific cells or into columns or rows, and it can also write like hyperlinks and URLs. So I'm showing you how to do that here. I'm just taking the Penguins data frame that we read in from using the OpenXLSX package, and then I'm creating a URL column with just this URL to Dr. Allison Horst's documentation on the Palmer Penguins package. And then I also creating another column called years since observation that calculates the years since the observations in the Penguins data set were taken. And I did that by using some Excel specific functions like these and specifying the column I where the years of the observations were located. So I'm going to go ahead and run this. That created this data frame. And then I'm writing this data frame that I just created or calculated to another separate Excel workbook. And we can see once I open this, that these URLs and formulas work. See? Note the URLs, you can click on the URLs and it'll lead you there. And then years since observations, you can successfully see that they calculated 15 years since 2007. Very cool. Okay. So any questions on writing or sharing Excel data?
I don't see anything in the chat. Does anyone have a question? Oh, wait here. Okay, someone wrote OpenXLSX will work in all cases, while read Excel package will not work in some cases.
I'm not sure if that's true. I think they generally work in all cases. Like it depends on what specific thing you're trying to do. Yeah, or the specific size of the file. But yeah, I know that, oh, actually, there's some things that OpenXLSX can do that Read Excel can't do. Like OpenXLSX can read and write password protected files and sheets, whereas Read Excel can't read in any type of password protected file because it doesn't have like a C++ or Java dependency. I'm not completely sure if Write Excel can write like password protected files, but yeah, I know that OpenXLSX has that edge over Read Excel in that specific area in terms of password protected sheets or files.
Thanks. There was another question from Yaw about writing a large data frame, asking, is Write Excel better for writing a large data frame?
Yeah, it would be faster. Yeah, and then also one thing that I would like to note about Write Excel is that when you write the same data frame with Write Excel and OpenXLSX, and our OpenSci blog post demonstrated this, for some reason, the Excel file written by the Write Excel package is smaller in size than the Excel file written by the OpenXLSX package. So not sure why, but yeah, it still preserves all the data. It's just, I'm not sure why it's smaller. And like our OpenSci post, I don't think specified why either, but yeah.
Thanks. Those are great questions, everyone. Any other questions? Okay. Oh, someone asked, what about splitting a data frame back into an Excel appropriate size if you concatenate? So I guess if you make something in R that has more rows, then you can write to an Excel file. Approaches to splitting it back up. I don't know, Josh, is that what you're asking?
Yes. Yeah. So if you do concatenate the size of the data frame, can extend beyond the 1,000,048 rows. But if you want to split it back into smaller sizes so that you can write it out to an Excel sheet.
Yeah, you can do that too. The tidyverse would also probably help you with that in terms of splitting the data into smaller sizes or into smaller data frames.
Okay, great. Thank you.
Mhm.
All right, other questions for now? Okay.
So moving forward, this is a summary of all of the R packages that I've showed you so far. I'd like to briefly go over this to like sum up all of the 5 steps that I've showed you. So Read Excel can only read Excel data into R, but it does it very well. It's 2 times faster than the other best package that can do this, OpenXLSX. Now, XLSX, Excel Connect, and OpenXLSX can help you along all of the 5 stages of this workflow. However, these 2 have Java dependencies. You can't run them both in the same R session because they have conflicting Java dependencies, specifically Apache POI. But OpenXLSX has only RCPP as a dependency, which makes it pretty versatile, pretty fast. And yeah, this is basically the package that I showed you throughout the entire 5-step journey of this analysis today. Then finally, Write Excel is like Read Excel in that it only can do one thing. It can only write data from R into Excel, but it does it really well. It's really fast, about 2 times as fast as OpenXLSX. And it has 0 dependencies like Read Excel, so they're both pretty versatile across different platforms and operating systems. So I've shown you how to work with Excel data within R and RStudio. There's another way on the flip side to do this with BURT, which is where you can work with R functions and R functionality from within Excel. BURT is the basic Excel R toolkit. It's free, open source. It's an Excel add-in to run R functions from within Excel spreadsheet cells, and it can write, like, you can create a function in R, and then you can call it from an Excel spreadsheet. But again, you're only limited by like the computational power and the memory size in Excel. And it's, again, a more effective mathematical alternative to VBA because you can use all of our statistical functions and capabilities and packages. Like, it's more powerful than VBA and Excel functions in that way. And it's also like another way to generate R's powerful visualizations in Excel. So if you'd like to learn more about BURT, feel free to check out more information and documentation at burttoolkit.com. So excuse me for a sec. Okay, so some additional references about how to use R with Excel. I wrote a guide a few years ago about how to use R with Excel. It has a lot of information in it, more than I can include in this presentation. So please check that out for additional information. There's also a tutorial called R for Excel Users by Dr. Julia Stewart-Landes and Dr. Allison Horst, the author of the Polymer Penguins package, which we use today. That goes into a lot of detail, and it was written for the RStudio conference in 2020. So I'd recommend checking that out. There's also Excel to R parts 1 through 3 by Matt Doncho that I'd recommend checking out as well. That provides even more information about how to interactively use Excel and R. So thanks so much for listening to my presentation. I hope it can help you use more like Excel and R interactivity together and like be able to utilize the benefits of both Excel and R. And if you have any additional questions, I'm happy to answer them today. And if you think of any questions later today or even later as you watch this video on YouTube, like you can stay in touch and email me via like just this email or via my website or LinkedIn or Twitter. So yeah, always happy to help. Thank you.
Thank you so much, Alyssa. That was an awesome presentation.
Thank you.
There was one question that that came up about Read Excel and Write Excel. Do they not have any dependencies?
Yeah, they don't have Java or RCPP dependencies in that way, but I think they have like other dependencies that are very lightweight and that they don't cause like problems when you're trying to like run things very quickly or like port things from different operating systems to each other. So I can just double check that really quick by going to like their CRAN pages. Yeah, here we go. How do I move this? Okay, there we go. Okay. Read.
Someone
Excel.
wrote in the chat that she thinks that Teresa wrote that she thinks they don't have any external dependencies. So it may be other R packages, but not any external software requirements. But I don't know. We could confirm
Right.
that.
Right. Yes, that would be correct. It just appears that there's other like R packages that don't have external dependencies here for Read Excel. And then for Write Excel, let's just see. Oh, whoops. Yeah. Cool.
Yeah, that's awesome. Are there other questions for Alyssa? I know I learned a lot. I've been using R for a really long time and used it with Excel, and I did not realize there were so many ways of interacting back and forth. I don't have to just write CSV files and then open them in Excel anymore. Like that's been what I do most of the time still. So yeah, so that's pretty cool.
Yeah, no problem. That would help.
Someone was asking about where they can get the references that you mentioned in the slides.
Well, I uploaded my slides to GitHub, and I believe the links work inside the PDF. Oh, that's weird. Here, let me put the links in the chat really quick. There's mine, and then here's Dr. Landis and Horse. And here's Matt Donches. There we go.
I'll put these links in the getting started guide as well then for future reference.
Cool.
Are there any other questions about the presentation? All right. I guess I'll go ahead and stop the recording. But then, yeah,